Hello viewers, welcome to the channel Amazing Civil Engineering Studies. Time to enter the world of civil engineering. Here we will learn about different concepts related to civil engineering. Please subscribe to the channel and press the bell icon for more new updates. In today's video we are going to discuss about building material. Aggregate, its classification, tests, and uses. Aggregates are an important part of a wide range of construction applications, used in domestic and commercial projects alike, and they make up a huge part of the composition of materials such as concrete and cement. Aggregates are, by definition, a collection of loose materials such as sand, gravel, and crushed stone. They are sourced from quarries, pits, and even from materials taken from the sea in some countries. Ready mixed concrete is made from around 80% aggregates, and asphalt consists of 95% aggregates. Aggregates are coarse particulate rock-like material consisting of a collection of particles ranging in size from 0.1 mm to 50 mm. It includes gravel, crushed rock, sand, recycled concrete, slag, and synthetic aggregate. Aggregate is a granular material, such as sand, gravel, crushed stone, crushed hydraulic cement concrete, or iron blast furnace slag, used with a hydraulic cementing medium to produce either concrete or mortar. Types of aggregates include coarse aggregate and fine aggregate. The aggregate of each type is further subdivided into many types and classification based on its size. The technique of sieve analysis is used for gradation of aggregate for use in concrete and for other applications. Aggregate is called bound material when it is mixed with cement or binding materials and referred to as unbound material when used without cement or binding materials. Classification of aggregates. The aggregate are classified by following categories. On the basis of geological origin. On the basis of shape. On the basis of size. Based on unit weight. Classification of aggregates based on geographical origin. The aggregate may be classified into natural and artificial, processed, aggregate. Natural aggregates. These are obtained by crushing from quarries of igneous, sedimentary, or metamorphic rocks. Gravel and sand reduced to their present size by the natural agencies also fall in this category. The most widely used aggregate are from igneous origin. Artificial, processed, aggregates. Broken bricks, blast furnace slag and synthetic aggregate are artificial aggregates. Broken bricks known as brick bats are suitable for mass concreting, for example, in foundation bases. They are not used for reinforcing concrete slabs. Blast furnace slag aggregate is obtained from slow cooling of the slag followed by crushing. The dense and strong particles as obtained are used for making precast concrete products. Classification of aggregates based on size. Aggregates are mainly classified into two categories. Fine aggregate, coarse aggregate, graded aggregate, all-in aggregate, fine aggregate. The aggregates passing 4.75 mm sieve and retained on 0.075 mm sieve are classified as fine aggregate. Types of fine aggregate. Usually, sand, crushed stone, and crushed bricks are used as fine aggregate in concrete or pavement construction. Typically, fine aggregates are used to improve workability of a concrete mix. For increased workability and for economy as reflected by use of less cement, the fine aggregate should have a round shape. The purpose of the fine aggregate is to fill the voids in the coarse aggregate and to act as a workability agent. Fine aggregate. Size variation. Coarse sand 2.0 mm 0.5 mm. Medium sand 0.5 mm 0.25 mm. Fine sand 0.25 mm 0.06 mm. Silt 0.06 mm 0.002 mm. Clay. Coarse aggregate. When the aggregate is sieved through 4.75 mm sieve, the aggregate retained is called coarse aggregate. Gravel, cobble and boulders come under this category. The maximum size aggregate used may be dependent upon some conditions. In general, 40 mm size aggregate used for normal strengths and 20 mm size is used for high-strength concrete. The size range of various coarse aggregates given below. Coarse aggregate. Size. Fine gravel 4 mm 8 mm. Medium gravel 8 mm 16 mm. Coarse gravel 16 mm 64 mm. Cobbles 64 mm 256 mm. Boulders 256 mm. Graded aggregate most of which passes through particular size of sieve are known as graded aggregate. All-in aggregate naturally available aggregate of different fractions of fine and coarse sizes are known as all-in aggregate. Classification of aggregates based on shape. We know that aggregate is derived from naturally occurring rocks by blasting or crushing etc., so it is difficult to attain required shape of aggregate. But the shape of aggregate will affect the workability of concrete. So we should take care about the shape of aggregate. This care is not only applicable to parent rock but also to the crushing machine used. Aggregates are classified according to shape into the following types. Rounded aggregates. Irregular or partly rounded aggregates. Angular aggregates. Flaky aggregates. Elongated aggregates. Flaky and elongated aggregates. Rounded aggregate. The rounded aggregates are completely shaped by attrition and available in the form of seashore gravel. Rounded aggregates result the minimum percentage of voids, 33%, hence gives more workability. They require a lesser amount of water-cement ratio. They are not considered for high-strength concrete because of poor interlocking behavior and weak bond strength. Irregular aggregates. The irregular or partly rounded aggregates are partly shaped by attrition, and these are available in the form of pit sands and gravel. Irregular aggregates may result 35–37% of voids. These will give lesser workability when compared to rounded aggregates. The bond strength is slightly higher than rounded aggregates but not as required for high-strength concrete. Angular aggregates. The angular aggregates consist well-defined edges formed at the intersection of roughly planar surfaces, and these are obtained by crushing the rocks. Angular aggregates result maximum percentage of voids, 38 to 45%, hence gives less workability. They give 10 to 20% more compressive strength due to development of stronger aggregate mortar bond. So, these are useful in high-strength concrete manufacturing. Flaky aggregates. When the aggregate thickness is small when compared with width and length of that aggregate, it is said to be flaky aggregate. Or in the other, when the least dimension of aggregate is less than the 60% of its mean dimension, then it is said to be flaky aggregate. Elongated aggregates. When the length of aggregate is larger than the other two dimensions, then it is called elongated aggregate, or the length of aggregate is greater than 180% of its mean dimension. Flaky and elongated aggregates. When the aggregate length is larger than its width and width is larger than its thickness, then it is said to be flaky and elongated aggregates. The above three types of aggregates are not suitable for concrete mixing. These are generally obtained from the poorly crushed rocks. Classification of aggregates based on unit weight. There are three weight-based variations of aggregates. Lightweight, standard, High-density different density aggregates will have much different applications. Lightweight and ultra-lightweight aggregates are more porous than their heavier counterparts, so they can be put to great use in green roof construction. For example, they are also used in mixes for concrete blocks and pavements, as well as insulation and fireproofing. High-density aggregates are used to form heavyweight concrete. They are used for when high-strength, durable concrete structures are required. For example, building foundations or pipework ballasting. Tests on aggregate. Aggregate plays an important role in pavement construction. Aggregates influence, to a great extent, the load transfer capability of pavements. Hence it is essential that they should be thoroughly tested before using for construction. Not only that aggregates should be strong and durable, they should also possess proper shape and size to make the pavement act monolithically. Aggregates are tested for strength, toughness, hardness, shape, and water absorption. In order to decide the suitability of the aggregate for use in pavement construction, following tests are carried out. Crushing test. Abrasion test. Impact test. Soundness test. Shape test. Specific gravity and water absorption test. Bitumen adhesion test. Crushing test. ATEST is standardized by IS 2386 Part 4 and used to determine the crushing strength of aggregates. The aggregate crushing value provides a relative measure of resistance to crushing under gradually applied crushing load. The test consists of subjecting the specimen of aggregate in standard mold to a compression test under standard load conditions. Dry aggregates passing through 12.5 mm sieves and retained 10 mm sieves are filled in a cylindrical measure of 11.5 mm diameter and 18 cm height in 3 layers. Each layer is tamped 25 times with its standard tamping rod. The test sample is weighed and placed in the test cylinder in 3 layers, each layer being tamped again. The specimen is subjected to a compressive load of 40 tons gradually applied at the rate of 4 tons per minute. Then crushed aggregates are then sieved through 2.36 mm sieve and weight of passing material, W2, is expressed as percentage of the weight of the total sample, W1, which is the aggregate crushing value. Aggregate crushing value equals W1/W2, *100. A value less than 10 signifies an exceptionally strong aggregate, while above 35 would normally be regarded as weak aggregates. Abrasion test. Abrasion test is carried out to test the hardness property of aggregates and to decide whether they are suitable for different pavement construction works. Los Angeles abrasion test is a preferred one for carrying out the hardness property and has been standardized in India. IS 2386 Part 4. The principle of Los Angeles abrasion test is to find the percentage wear due to relative rubbing action between the aggregate and steel balls used as abrasive charge. Los Angeles machine consists of circular drum of internal diameter 700 mm and length 520 mm mounted on horizontal axis, enabling it to be rotated. See figure. An abrasive charge consisting of cast iron spherical balls of 48 mm diameters and weight 340 to 445 GIs placed in the cylinder along with the aggregates. The number of the abrasive spheres varies according to the grading of the sample. The quantity of aggregates to be used depends upon the gradation and usually ranges from 5 to 10 kg. The cylinder is then locked and rotated at the speed of 30 to 33 rpm for a total of 500–1000 revolutions depending upon the gradation of aggregates. After specified revolutions, the material is sieved through 1.7 mm sieve and past fraction is expressed as percentage total weight of the sample. This value is called Los Angeles abrasion value. A maximum value of 40% is allowed for WBM base course in Indian conditions. For bituminous concrete, a maximum value of 35% is specified. Impact test. The aggregate impact test is carried out to evaluate the resistance to impact of aggregates. Aggregates passing 12.5 mm sieve and retained on 10 mm sieve is filled in a cylindrical steel cup of internal diameter 10.2 mm and depth 5 cm, which is attached to a metal base of impact testing machine. The material is filled in 3 layers where each layer is tamped for 25 numbers of blows. See figure. Metal hammer of weight 13.5 to 14 kg is arranged to drop with a free fall of 38.0 cm by vertical guides, and the test specimen is subjected to 15 numbers of blows. The crushed aggregate is allowed to pass through 2.36 mm as sieve, and the impact value is measured as percentage of aggregates passing sieve, W2, to the total weight of the sample, W1. Aggregate impact value equals W1/W2 *100. Aggregates to be used for wearing coarse. The impact value shouldn't exceed 30%. For bituminous macadam, the maximum permissible value is 35%. For water-bound macadam base courses, the maximum permissible value defined by IRC is 40%. Soundness test. Soundness test is intended to study the resistance of aggregates to weathering action, by conducting accelerated weathering test cycles. The porous aggregates subjected to freezing and thawing is likely to disintegrate prematurely. To ascertain the durability of such aggregates, they are subjected to an accelerated soundness test as specified in IS 2386 Part V. Aggregates of specified size are subjected to cycles of alternate wetting in a saturated solution of either sodium sulfate or magnesium sulfate for 16–18 hours and then dried in oven at 105 to 1100 C to a constant weight. After 5 cycles, the loss in weight of aggregates is determined by sieving out all undersized particles and weighing. The loss in weight should not exceed 12% when tested with sodium sulfate and 18% with magnesium sulfate solution. Shape tests. The particle shape of the aggregate mass is determined by the percentage of flaky and elongated particles in it. Aggregates which are flaky or elongated are detrimental to higher workability and stability of mixes. The flakiness index is defined as the percentage by weight of aggregate particles whose least dimension is less than 0.6 times their mean size. Flakiness gauge, see figure, is used for this test. Test procedure had been standardized in India. IS 2386 Part I. The elongation index of an aggregate is defined as the percentage by weight of particles whose greatest dimension, length, is 1.8 times their mean dimension. This test is applicable to aggregates larger than 6.3 mm. Elongation gauge, see figure below, is used for this test. This test is also specified in IS 2386 Part I. However, there are no recognized limits for the elongation index. Specific gravity and water absorption. The specific gravity and water absorption of aggregates are important properties that are required for the design of concrete and bituminous mixes. The specific gravity of a solid is the ratio of its mass to that of an equal volume of distilled water at aspect feed temperature. Because the aggregates may contain water-permeable voids, so two measures of specific gravity of aggregates are used. Apparent specific gravity and bulk-specific gravity. Apparent specific gravity, G. Ap, is computed on the basis of the net volume of aggregates I.eth volume excluding water-permeable voids. Thus G. Ap equals M. dV N/W, where M d is the dry mass of the aggregate, V Nis the net volume of the aggregates excluding the volume of the absorbed matter, WIS the density of water. Bulk specific gravity, G. Bulk is computed on the basis of the total volume of aggregates including water permeable voids. Thus G bulk equals m dV b slash W, where m d is the dry mass of the aggregate, WIS the density of water, v bis the total volume of the aggregates including the volume of absorbed water. Water absorption, the difference between the apparent and bulk specific gravities, is nothing but the water permeable voids of the aggregates. We can measure the volume of such voids by weighing the aggregates dry and in a saturated surface dry condition, with all permeable voids filled with water. The difference of the above two is m W m W is the weight of dry aggregates minus weight of aggregates saturated surface dry condition. Thus, water absorption equals m W m d Asterisk 100. The specific gravity of aggregates normally used in road construction ranges from about 2.5 to 2.9. Water absorption values ranges from 0.1 to about 2.0% for aggregates normally used in road surfacing. Bitumen adhesion test. Bitumen adheres well to all normal types of road aggregates provided they are dry and free from dust. In the absence of water, there is practically no adhesion problem of bituminous construction. Adhesion problem occurs when the aggregate is wet and cold. This problem can be dealt with by removing moisture from the aggregate by drying and increasing the mixing temperature. Further, the presence of water causes stripping of binder from the coated aggregates. This problem occurs when bitumen mixture is permeable to water. Several laboratory tests are conducted to arbitrarily determine the adhesion of bitumen binder to an aggregate in the presence of water. Static immersion test is one specified by IRC and is quite simple. The principle of the test is by immersing aggregate fully coated with binder in water maintained at 400 C temperature for 24 hours. IRC has specified maximum stripping value of aggregates should not exceed 5%. List of IS codes related to aggregate testing. Tests for aggregates with IS codes. Property of aggregate. Type of test. Test method. Crushing strength. Crushing test. IS 2386, Part 4. Hardness. Los Angeles abrasion test. IS 2386, Part 5. Toughness. Aggregate impact test is 2386, Part 4. Durability. Soundness test is 2386, Part 5. Shape factors. Shape test is 2386, Part 1. Specific gravity and porosity. Specific gravity test and water absorption test is 2386, Part 3. Adhesion to bitumen. Stripping value of aggregate.is 6241 to 1971. Why we use aggregate in concrete. Following are the reasons why aggregates are used in concrete. They are easily available and they are economical as compared to cement. Aggregates provide additional strength to the concrete. Aggregates helps in binding the cement properly. If properly graded aggregates are used in concrete, i.e., fine and coarse, then the voids in the concrete will reduce and thus creating more strength. If the concrete is made only with cement, it will shrink more and relatively more water is required for the cement to form workable paste, so more amount of water means decrease in strength and shrinkage, causing cracks in the concrete. So it is necessary to use aggregate as they decreases the cement content and so water content and increasing its strength. Thank you for watching. For now, please subscribe, like, share and do not forget to press bell icon.